So in this video we'll be learning about parametric equations and how can we use them. So let's start with the basic graph of axis and y axis, and let's say that we have an object over here, this dot, and we have a trajectory, a random trajectory, and this is the final point. So I'm gonna note the initial point as initial point and the final point as the terminal point. And one thing to remember is that the direction is very important. So this is going like this, and as this is a x-axis and y-axis graph, let's just denote this point by x of I is initial, and here the point will be y of I, and for this terminal point let's denote it by x of f as final and then y of f. Now the main thing in parametric equations is that our t is the variable. So we have x and y, and then we have another variable called t, and in the initial point our t is going to be t of is equal to 0. This point, for example, let me just do it with a different color maybe. So this point is t is equal to 1, this point, for example, is t equals to 2, and so on. So our main parametric equation is, let's say at this point, to find x and y, you have to do x of t, the variable, comma y of t, and this is what the parametric equation is called. So now the general approach that you have to take is, whenever you have a question like this for a parametric equation, the first step is always to graph it. So first step, graph, and observe the equation. Second step is that we are going to try to convert the parametric equation into Cartesian equation, meaning we have x of t and y of t, so we want to remove the dependency on t and change it into y of x, so that we are not dependent on t anymore. Now thirdly, the question may also ask you to find the derivative of the Cartesian or the parametric equation, so that might be another part in your question. Also, some questions might ask you the length of the equation, and another question might ask you the surface area, so finding the area if it is being revolved against the x-axis or the y-axis. So now let's start with the examples and questions. So our first question, we have x is equal to radical t, and then we have y is equal to t, and we have a limit on t, which is t is always more than or equal to 0. So now the first step is to graph this. So let's take some points for t, x, and y. So let's take 0, 1, let's take values which can be square rooted. So let's take 1, 4, and 9 and find the values for x and y. So when t is 0, we are gonna get 0 and 0 for x and y. When t is 1, we are gonna get 1 and 1. T is 4, we are gonna get 2 and 4, and when it's 9, it's gonna be 3 and 9. So now we have the values. Now let's draw a grid, and remember that t is always more than or equal to 0. So let's point these values. 0, 0, 1 is going to be right here, and then we have 2 and 4, so 1, 2, 3, 4 right here, and let's do 3, 4, 5, 6. I'm just gonna guess it right over here. So right here somewhere. And now if we draw the line, it is gonna look something like this. Now, does this graph remind you of anything? This is a parabola, right? It's like a U, because normally when you have x squared, it looks like this, but since we have t is more than or equal to 0, it is only the half over here, so this part. So also keep that in mind, that the direction is very important here also. So what is our first value? Is going to be 0, and then 1, and then 4 and 9. So we are going upwards, right? So always remember to put the sign or the direction. So let me just clear that one more time. Yeah. So now the next step is to convert the parametric equation into our Cartesian equation. So we have x is equal to radical t, and we have y is equal to t. So do you see any way to equate y is equal to x in some way? What we can do here is that we can square both of this side. So it's going to be x squared is equal to radical t squared, which is going to cancel out the radical. So we are left with x squared is equal to t, and here we have y is equal to t. So we can just replace the t with x squared. So we have y is equal to x squared. Now we did get the Cartesian equation, which is y is equal to x squared, but this is a u, and here in our graph we only have the right side, which is the positive side, since t is more than 0. So do you see any restriction that we can have in our Cartesian equation that can limit the graph to only the right side? We can do x is more than or equal to 0. And now we only have this graph over here. So that's it. That is the final answer. And let's move on to question 2. So in our question 2, we have x is equal to t squared, we have y is equal to t plus 1, and this time we have t as between positive infinity and negative infinity. So again, let's start by graphing this equation. So we have t, x, y, and now let's take some values for t. So I'm gonna take -2, -1, 0, 1, and 2, the most basic values, and we get 4, -1, 4, -2, 1 and 0, then 0 and 1, 1 and 2, and finally 4 and 3. So now let's graph it. And sorry about my graph, it's not that clear, but you have to bear with it. So this point I'm going to take it as 2, 1, 2, 3, 4, and then we have this is going to be 1, or sorry, -1. So we have 1 point over here, and then we have a 3 over here, and then a second point over here, and then somewhere over here. And now if we graph this, we are gonna get a parabola which looks like this, and this is x is equal to y squared parabola, if you have seen this before. And again, the direction here is going to be, since this is a starting point, -2 is going to start from here, this direction, and then go like this. So don't forget that. Now the next step again is to find the Cartesian equation. So here we have x is equal to t squared and y is equal to t plus 1. So the first thing that comes to mind is, let's isolate the y over here, or sorry, the t over here, So it's going to be y minus 1 is equal to t. And now if we substitute back into this equation, we have t, so we're just going to square it, and then x is equal to y minus 1 squared. Now another thing you might be thinking is, what if I can square root x over here and just substitute t here? So what I mean by that is radical x is equal to t, and if we go back to this equation, it's going to be y is equal to t, which is going to be radical x plus 1. Now one thing to always keep in mind is when you are taking the square root, that x could be positive or negative. So in that case, if you're taking, you need to check for both cases. So that's why I don't want to do that and just take this way. I mean, both answers are correct, but for the second method you would have to try the values and check if the x is positive or negative. Actually, let's do an example there. So we had the equation of radical x plus 1 is equal to y, right? Now let's try these values. We are gonna get radical 4 plus 1 is equal to negative 1, right? And this is not the case because it's going to be 2 plus 1 is equal to negative 1, which is wrong. So here we should have took a negative radical. So if we switch it now, it's going to be negative 2 plus 1 is equal to negative 1, which is correct. So basically you could use the second method, but whenever you're square rooting something, you need to check for both the signs. So anyways, both answers are correct. So now let's look at a different kind of question, question 3, where we have a circle. So question 3, we have x is equal to cosine t and y is equal to sine t, and we have t between 0 and pi, 2 pi. So now let's again take test points for t, x and y. So when t is, it has to be, remember, 0 to 2 pi, right? So we can only take 0, pi over 2, and then pi, 3 pi over 2, and then we can take 2 pi. And when 0, it's 1 and 0, 0 and 1, negative 1 and 0, 0 and negative 1, 1 and 0, and this is x and y. So now let's graph it. So we have the test points as the first point is 1 and 0, so this is our initial point. I'm gonna point it over here, and then we have pi over 2 as 0 and 1, so this is our next point, this is our next point, and this is our final point. So now we can join the points like this, but how do we know that it's a circle? So let me just do it again, sorry. How do we know that the points are not being connected like a straight line, so like this? Or it could be also connected like a arc, but the other way around. So don't make assumptions, you have to check the point. So there are multiple ways to do this. So the first point, or the first step, or the method is to take another point between 0 and pi over 2, so pi over 4, and this way you will know that the point is either here, here, or on the circle. Another point, another easy way that we have over here, actually, oops, this happened, okay. Is that if you see this equation, we have x is equal to cosine t, y is equal to sine t, and if you recall the most basic trigonometric equation, which is cosine, or actually sine squared t plus cosine squared t is equal to 1, and here we have y as sine t, so it's going to be y squared plus x squared is equal to 1, which basically proves that it is a circle. So there's multiple methods. You can take a point between 0 and pi over 2, pi over 4, and if you get, let's say, x value which is on the circle, this means it's a circle. If it's here, this means a straight line, or this point. So yeah, and this is the equation, the Cartesian equation. And I almost forgot to add the direction over here. So we have t0, this is the initial point, as this one, so it is going like this. So now let's move on. Question 4. We have x is equal to 1 plus sine of t, y is equal to cosine t minus 2, and we have 0 between t0 and 2 pi. So let's start by taking the values. So we have 0 pi over 2, pi, 3 pi over 2, and then 2 pi. And it is going to give us 1 and negative 1. Next point is 2 and negative 2, 1 and negative 3, 0 and negative 2, and 1 and negative 1. So now if we graph this, it is gonna give us below the x-axis, since all of our y's value are negative, so the graph is gonna be something like here. So let me just point the dots. First one is, okay, let's not do that because it's going to be very small then. So let's take something over here. So this is 1 actually. So here and here are the points. And now again, you notice that either these points can be joined, straight line, it could be a curve, or inside curve. So let's take another point here, t, as pi over 4, and we are gonna get, for x and y again, 1.7 and negative 1.3. So we know that the point is going to be somewhere over here, since it's below above 1.5, it's going to be somewhere over here. So this means that it is a circle again. So now let's join the points. It's going to be something like, oops, and now the direction is going to be like this, right? Yes. Now the final thing again that's left is to find the Cartesian equation. So here we have x is equal to 1 plus sine t. So here I'm going to take 1 to the other side and isolate sine t. So it's going to be x minus 1 is equal to sine t, and then we have y plus 2 is equal to cosine t. And now again, if we apply that same equation or formula of sine squared plus cosine squared is equal to 1, we are going to be left here with x minus 1 squared plus y plus 2 squared is equal to 1, and this is the final answer. So that's all for this video. If you have any questions about anything that we covered in this video, feel free to ask in the comment section. I'll be more than happy to answer. And as always, thanks for watching, and I'll see you next time.